Hi, I'm an old guy and I do maths, and today we're trying to figure out how a person achieves maximum area of enclosure when there is a fence along here and they have 40 meters of fencing available to them. Now, most people know that a square is the most efficient rectangular way in which to enclose space. But this is a little different because we're really working with three sides here rather than using this to get a four-sided figure. I'll explain a little bit more once we get going. So you'll have read the header. The story goes that someone wants to house their dog in a safe area. They've got 40 meters of fencing to use, and they've got an existing fence which they can build out from. Okay, so the key to this is to get an equation for the potential area. So let's go to work on that. Now, if we call this side x and this side x, then this length here must be 40 minus 2x. And our area calculation is going to look like this. Okay, so let's expand that. So we get 40x minus 2x squared. Now that's our expression for area. And what we're looking for is we're looking for a maximum. So, big clue. We're going to have to use calculus. We're going to have to differentiate because that will give us a maximum and a minimum. Okay, and at the point where the differential equals 0, we've got either a maximum or a minimum. Looking at this, the nature of this equation tells us that we're going to have a maximum. Now, why? Well, I'll just do a quick sketch of what this might look like. It will look like that. It'll be an inverted parabola, and our maximum will be there. Okay, let's go to work. So the differential of this, so if we just call this f dash for the sake of brevity, is going to be 40 minus 4x, and we're going to make that equal 0. That's not too tough. Negative 4x equals negative 40, 4x equals 40, x equals 10. Now, that's a slight surprise, given that I said earlier that the most efficient way in which to enclose space is to use a square. So why this? Well, it's to do with the fact that we're basically using 3 edges, not 4. So indeed, if we had a square with 10, 10, 10, 10, that's a perimeter of 40, which is what we've got here, and we would have an area of 100. Okay, now what we're going to wind up with here is something slightly different. So if that's 10 and that's 10, this must be 20. We'll put the dotted line across there just to represent the fence. So 20 times 10, 200. A bit of a surprise, I expect, but it is to do with the fact that we are using the fencing that we have available to us on only 3 sides. Now, let's just check this out and see see if there's any evidence that we've got the maximum here. So what we're going to do is we're going to make x equal 9, and that means that we're going to have 9 and 9 is 18. This is going to be 22 by 9, I think. So let's just try that. 22 by 9. That gave us 198. We're down a bit. Let's try 18 by 11. So make this 11, therefore that is 18. Um, 198. And given the way that our graph looks, we are going to be falling off in this direction and this direction. So we have found our maximum, which is going to be 200 square meters. I think it is. Yes, that's 40 meters. And x equaling 10 gives us the absolute maximum area we can enclose using the existing fence and 3 other sides of new fencing. Okay, well, I hope that was interesting and helpful. If it was, please like and subscribe, and I'll see you next time. Bye.